Welcome to Game Engine series. Today's topic is going to be window creation. But first, let's ask ourselves a very simple question. What is a game engine and what defines it? Surely Jason Gregory knows more than we do, and the short answer is yes, but in reality, this has way too much complications than we need. I guess this brings us to something much more simple, like Game Engine is a tool which allows you to create your game. Do not try to make a feature-complete engine like Unity or Unreal from scratch. Focus on your game which you want to make and create features from that. Nevertheless, we have to start from something more reasonable. Essential things like our drawing canvas, that is, window. Besides that, engine might have multiple windows, so some way of managing them would be nice. Let's first of all decide about the main function, or the main loop. There are two common ways to handle that. First is polling, which is the most used one, and all popular engines have it. The idea is simple. You render something at a frame rate, and constantly check, for example, for keyboard input. While event-based method relies behind the idea that image on the screen cannot be changed without some input or interaction. It is more efficient, but does not fit games at all, because image constantly changes there. Next, let's imagine what we would want from our window system. There's probably going to be the main window, editor, and optionally some secondary windows like mesh viewer. Therefore, our application cannot own and track just a single window, and we need some way to manage them. That's where a window manager comes in. Since input is not window specific, we're going to poll events from our manager in a main loop until the application needs to be closed. The interface is simple: initialization and destruction, addition and deletion of our windows which we want to manage, method for checking input events, requests for application to close, and a check if it should be closed. This is implementation for Windows platform because it has instance variable, which is kind of like a unique identifier of your program for WinAPI calls. Initialization and destruction is simple. Simply retrieve an instance handle with optionally provided module name and call destroy method for every managed window. I've decided to close our application when all of the windows are closed, but that's not always the case if you have offline rendering, for example. Event polling in Windows is basically a while loop for every single message in a queue retrieved by peek message function. First argument is a message you will receive. Second argument is a window handle which you want to receive messages from. So yes, this loop can be inside each window instead of a manager, but that's probably not necessary until your windows run in different threads, and even then there are other ways to handle that. Null basically means that message might be from any window. Next two arguments provide a filtration if you want to check just specific messages. And the last argument instructs to remove or not to remove a message from a pending queue. If we received a quit message, it's only natural to just close our application. Otherwise, we will first translate our message, which, for example, will convert raw keyboard input into actual characters. Because you don't have a shift character, but you can use it to generate capital letters. Dispatch function basically sends a message into per window callback, which we will define later in a window class for further input handling. Let's finally start with our window class. Class name and context name can be named whatever you want, but they are necessary for Windows API. Same as manager, we should be able to initialize and destroy a window, close it, and check if it should be closed. We will store a manager which handles our window, a Windows handle, and a configuration like width and height. First of all, we have to create a window class using register class function for further use inside create window function. We will provide a style which will redraw our window whenever it's resized both vertically and horizontally, and have a unique device context, which is useful if you want custom pens, brushes, and font for your window. Window process is a callback, which will be called after dispatch message function in a manager. Application instance, class name, cursor, and icon should be pretty much self-explanatory. Next, we need to create a rectangle, which will decide our window's x and y coordinates, width and height. If our window is not borderless, there's a top bar with a logo, window name, as well as minimize, maximize, and close buttons, which are not taken into account with our rectangle. AdjustWindowRect function does just that. It resizes dimensions so that your actual drawing canvas width and height match your desired values. We can finally create our window. Since title can be written using any language, we have to create a white string for that. First argument is extended style, which is 0 in our case. Possibly useful 9th argument is a pointer to a parent window, and 10th argument is a pointer to a window menu. After window creation, we will save our window class inside of a context, which can be obtained by a window handle, necessary for input handling later. Finally, we can show our window to the world, using showWindow function. Let's discuss something we missed. Our window style has some fixed parameters, like clip siblings needed for drawing overlapping child windows, clip children, which excludes the area occupied by child windows when drawing occurs within the parent window. SysMenu provides a menu on a Windows title bar and requires caption style to also be specified. A minimize box provides a minimize button. Caption provides a title bar. Maximize box provides a maximize button, which only possible if our window is resizable. Thick frame provides a sizing border. Pop-up is kind of like self-explanatory. Just remember Windows errors popping up in front of your screen. Extended style has a single option, which forces a top-level window onto the taskbar when the window is visible. Conversion of our title to white string is straightforward. First, use multi-byte to white char function to determine the size of an output string, and then use the same function for actual conversion. The last piece is the handling function for input. First of all, we want to get our window class from the context we stored earlier. Then, we can get to message processing. If window should be closed, we will destroy it and free all its resources. Upon destruction, the according message is sent to, where we can decide whether to close just a single window, if it's a mesh viewer for example, or to close all windows because our main window editor got shut down. If our window got resized, then we should update internal variables accordingly for correct tracking. In the end, we should call default windows process to handle the rest of the messages. Window destruction is symmetrical to creation, but in reverse order. We first destroy our window, and then unregister its class. And there we have our two windows, which can be dragged and resized. We can freely close the second window, and shut down everything upon main window closure. Hope you enjoyed the video, and thank you for watching.